Hi, and welcome to TEMEKO. In this video, we are going to learn how to formulate the angular momentum of a particle in both planar and spatial cases. During the video, we'll also get familiar with what kind of relation the moment of a force and angular momentum have with each other. Let's get started. Let's first discuss what is meant by the angular momentum of a particle. It's possible for us to consider the angular momentum to be a moment which is caused by the particle's linear momentum about a certain point. Now, can you notice the similarity to the moment which is caused by a certain force? Yes, they are similar, which is why we can also call the angular momentum of a particle as the moment of momentum. Now, in the planar case, we can formulate the scalar equation for the angular momentum of a particle as follows. HOZ equals d times m times v, where d is the moment arm of the particle's linear momentum m times v. The common unit that we use for this angular momentum is kilograms times meter squared per second. Notice also that the angular momentum of a particle is actually a vector of which the direction can be defined by using our familiar right-hand rule. In reality, however, the particle would be more likely to be moving along the space curve because our world is three-dimensional. Therefore, to determine the angular momentum of a particle about point O in a spatial case, we would have to use the cross product. In this case, we could express the angular momentum by using the following mathematical expression. HO equals R cross m times v. To solve the cross product between the position and particle's momentum vector, it's recommended for you to use the Cartesian notation so that it's possible to determine the angular momentum from the following determinant. Now that we are familiar with how the angular momentum of a particle can be formed and expressed in both a planar and spatial case, let's discuss about the relation between the moment of a force and angular momentum with more specifics. As you may know, the particle is usually subjected to many external forces at the same time, which is why we can write the relation of all the forces acting on the particle's linear momentum by using the equation of motion as follows. Summation of F equals m times v dot, which we can also write as summation of F equals L dot. Note that we are assuming that the mass of the particle won't change anytime, which is why we can use the presented relation. By using this relation, we can define the moments about point O, if we are taking the cross product of each side of this equation by the position vector r. This resultant moment about point O is actually equal to the time rate of change of the particle's angular momentum about point O, which can be proven by taking a time derivative of the angular momentum of a particle as follows. Which would eventually lead to the following statement. Hopefully, by watching this video, you are familiar with how we can formulate and determine the angular momentum of a particle in both a planar and spatial case. You are also aware of what kind of relation the momentum of a force and angular momentum have with each other. Thanks for watching and have a nice day.